Good to go?
I already started the camera. I already started. Oh, you did? Okay. Yeah.
We're good then? Okay. Today I'm going to talk more about Elixir. And I talked about Elixir before, but I talked about like processes and like, more technical stuff. But today I want to talk about some of the reasons that writing Elixir is fun to write, which is definitely, an important thing when we choose a programming language because we want to enjoy our lives. And Ruby and Python are really enjoyable languages to write code in. And most of the day-to-day, you're maybe not super focused on writing processes and spitting out hundreds of nodes and handling 2 million connections, and that's all really, really cool stuff, and it's great to be able to do that. But in reality, the request is, if you can process requests concurrently, then that's half the battle. So let's talk about just writing actual code. So the first cool thing that you probably heard about in Elixir is the pipe operator. And it's just like the bash pipe, if you're familiar with it. And it just takes the result of something and pushes that as the first argument into the next thing. So rather than writing this really hard to read first example, you could use the pipe operator to make it a little nicer. And it breaks nicer over multiple lines. And this, of course, is like a trivial example, but this pipe operator has become kind of, APIs are driven by the use of this pipe operator now in Elixir because it creates really nice, easy to read code. And especially in a functional language with argument passing, a lot of times they say you want to make the first argument to any function in Elixir the most important argument. So in Phoenix, for example, like the connection is the first argument to everything. And it's just like this big ball of data. And so by having it be this big ball of data that you pass as your first argument, you have really chainable APIs that you can go through with the pipe operator. In Ruby, we might write something like this, and we just have like keyword arguments represent different pieces of thing, and it creates this new email object, and then we'd have like a deliver method or something like that on our email. In Elixir, what is happening here? Oh dear. What did I do? Somehow I broke preview. Oh, there we go. In Elixir, we would write this. So you just say new email, and then you chain to 2 and pass the new email as the first argument from email as the first argument. And this is constantly just updating what that original new email thing was. And each one of these functions is going to return a new email object that has some additional data attached to it. So as you can see, like this is a lot cleaner than if we were to write like new email.to.from.subject.html body and have that be like immutable and all that fun stuff. So the other core driver of syntax and the way you write Elixir code is pattern matching. So APIs generally return responses that can be pattern matched upon. So for example, it's important to know first that the equal symbol is not like an assignment operator, it is a match operator. So these two expressions are both exactly the same. X equals 1 and 1 equals x. In lists, you can pattern match, you can get all the items in the list. Maps are the same way, including structs, because a struct is a subset of a map. And you can just grab different pieces of data out of these things. And if you're familiar with ES6 destructuring, this is kind of similar, but definitely not the same. And then tuples are one of the most common responses from different Elixir libraries that you'll use. And they're specifically for pattern matching. Like that's their whole goal. And often, something will return either error and then whatever the error was, or okay and whatever the good stuff that you wanted was. And when a pattern doesn't match, so for example, if I do an HTTP request and the HTTP request fails, then I would get back error and like the actual error object thing. And if I did get that back, in this case, because I said it's going to come back as OK with response, it's going to actually raise an error. So this is a way that you're kind of forced into handling errors at the get-go, and you know what could possibly go wrong because you know that this thing could return error or something else. You have to handle that case. So I think it makes you write better code. And it's also useful because you're like, yeah, it's probably going to be fine, and let it blow up, it's fine, and it'll explode here, and then you'll just figure it out later that you should probably handle that error. So one of the ways we handle errors is using the case expression. And you just have the first thing that you put between case and do be the thing that you want to test, and then each match here will be the possible thing you could get. So like if we get OK and then the response, we're going to log it. If we get error, we're going to log out the error. And there could be an infinite number of these possibilities. And it doesn't strictly have to be error or OK. That's just what they commonly are. You might get connection refused or something like that. So we can also, our functions can have multiple implementations that pattern match. So rather than having like an if statement, like if the first thing was an error and the last thing is a response, if the first thing is, you don't have to do that. Your function can handle that, and it keeps your code really clean. So I can run my HTTP request, and I'm going to pipe the result of the HTTP request into this log function. The log function, assuming that the response came back successfully, will log it. If it came back with an error, we'll error it. And if anything else came back, we'll just have a fallback. And this underscore just matches anything. So, and then there's guard clauses, which are, if pattern matching can't do it, that's kind of where the guard clause comes in. So you might write something like this in another language. It's pretty bad. Hopefully you wouldn't nest your conditionals, but that's bad. The reason I didn't nest conditionals here is because I'm fairly certain that Elixir doesn't actually have else if. So that's something. So here we just pattern match. So if you don't get a dog, which is like the most common thing, like a nil check is so often it's return of nil, you can handle that here before it invokes all these things and say you got no dog. And it's important to note that these are checked in the order that they're declared. So if I put this above these, this would always match, which would be a problem. And so this is the match, and then this is a guard. So when ID is greater than 5 is I'm pulling ID out of this map, and then I'm saying when the ID is greater than 5. So that's where guard clauses come in, and that's how. So if the match matched, but the guard didn't pass, then it would continue on to the next possibility. Greg, you had a question?
Are there static analysis tools that will flag things like you put the wildcard matcher first and you had?
Yeah. So if I put this first, I think it would actually tell me it's like this is always going to match. You probably shouldn't do that. So yeah, usually it can detect that, and also in the back here. So like if you do a case statement and I had just like the word something here, it would say, hey, that's always going to match. You're never going to ever hit this error thing. So it's pretty smart about it. Yeah. Obviously, it can't be as smart about guard clauses because, Okay. Did I already do case? Yes, I already did case. So here's another example of case, just saying you could have an unlimited number of these things. If you got timeout, you can match that as well. I don't know why I did that twice. So then there's this thing called with that came out with Elixir 1.3. And so the case statement's really nice when you're doing one conditional, but then if you're doing one conditional and then you're doing another thing within it, you get this crazy nesting going on, and it gets really ugly really quickly. So the solution for this was this extremely elegant with macro. So we say with OK record, that means if I got the record and OK back, then we're going to go ahead and sync it, assuming we get OK and response back. We will then, return OK record response. If at any point in this with, the expected message didn't come back, like it didn't match the pattern, it would just return whatever the error thing was that didn't match. So whatever the result of this was that didn't match this pattern would come back. Does that make sense? So it's way more expressive than that previous ball of code, and it does literally the exact same thing. So, and you could also put an else on here that would allow you to, control how that error comes back.
It's where you controlling the error piece, or how does this control the error piece? Because in the previous
Yeah.
one, you had
So the error would just pass through. Like,
something outside of this method.
yeah, so say this, for example, returned error change set instead of OK record. This whole expression would just stop. It would never go to here, and it would just return error change set. Does that make sense? It would just, this whole thing would be thrown in the trash, and it would just return the result of this function. Yeah, sure. So it basically returned this in the case that it didn't match. Yeah.
What if you want to handle that error before returning and do something with it?
You could do that. You could just assign like result equals with, or there, like I said, there's also an else in addition to do that would allow you to like return a custom error. And then we get to macros. I never used Lisp or anything like that, so I'm not that familiar with macros. But when I saw them in Elixir, I was like, whoa, that's pretty cool. And actually, it's important to note that this is the GitHub for Elixir, the language. Elixir is 88.6% written in Elixir, which is pretty incredible. And that's largely due to their use of macros, I think. Like most things in the language are just macros. Like if, for example, is a macro, unless is a macro, with is a macro. So these things that are normally like language built-ins, like def in Ruby that you have no control over. You can't like alter how def works in Ruby or how class works in Ruby, but in Elixir they're just macros, so you kind of can. Yeah, so macros. So there's this thing called quote that will take some Elixir code and it'll deserialize it into this, where it's the function name, the keyword list containing metadata, which I don't even know, and then the list of arguments to the function. And being a pretty simple data structure, you can imagine that you could probably parse this without too much difficulty.
Sorry, what was the second? Or the second?
It's a keyword list containing metadata. I don't have an example of it, and I don't remember an example of it, so sorry. And you can take a quoted expression, and you can get the original source back from it. So, once this is quoted, I can get back what I originally had written, which is nice. And that's cool, but you can also, so note how number here just comes through as just number, not as 13. And that's because it's literally quoted. But you can unquote and escape the quoting and get the actual number in there. Good question, Dustin. Thank you for asking that. So for example, the X unit, which is Elixir's testing library. So in many languages, like Ruby, we would say, expect something to match this pattern in our test. And that's how it would generate a nice, useful error message, like expected this string to match this regular expression. It knows how to generate that message because you tell it how to generate the message when you're writing your test code. But in Elixir, you just write assert, which is a macro. And then you can do the match operator, and it's able to parse that and give you back what you had originally written in addition to what the left and right hand sides were. So this is like, a good example of why that's useful. I'm not sure how many other really useful use cases there are, but it is cool. It's definitely cool.
So in this example, if you had insert who is equal to bar plus number,
Hmm. It would show that, yeah.
the code line would say bar plus number and then say what
Yeah, yeah,
with the actual like evaluated result.
right, yeah. Because it like knows what you had originally written, and it knows what was on the left and right-hand side.
So that probably is important in a functional language to have macros so that you can create expressive DSLs.
Right, yeah, definitely. I'll get to that though.
Okay, cool.
Yeah. So here's an example of a macro. Actually, this isn't a macro. I'm going to show you how a macro is different than a regular function. So I created this IIF function, which is like the IIF function in SQL. And basically, if the first argument will be a test, the second will be our positive case, the latter will be our negative case. And so I'll say IIF false, output A, otherwise output B, and the inverse. So what would you guys expect to happen here? How do you think this is going to go down? Right. There's going to be 4 lines. It's going to be A, B, A, B, because you wrote it and it's immediately evaluated. And you're right. So smart. So now let's write this as a macro. So we say def macro, and we unquote the arguments that we passed in. And now, I'm sure you can guess what we're going to get. We actually just get BA, which is what we thought we wanted, but we all know that that wasn't going to work how we had hoped it would until now it's a macro. So you can kind of control when this code actually gets evaluated. Whereas in a language like Ruby or JavaScript, you have like blocks or anonymous functions, and that's how you would do something like that at runtime. But this, you're instructing it at compile time not to evaluate that code.
So the macro by default quotes all its arguments. Because the fact that it's a macro, is that what's preventing IIFS from actually being evaluated because it is
Yeah. Yes.
somehow-
Because it's, yeah, I think, if I know what you're
So
asking.
quoting is just like evaluating it as code. Or unquoting, sorry.
Right, yeah, it's like run this right now. Yeah.
If it's automatically applied, you have to quote new there, right?
Oh, yeah. I mean, you do have to explicitly quote.
Yeah, what does that quote do?
Otherwise, it would just run the if.
Right. Yeah, it would run it immediately when you called it, I guess.
You have to return the code that you want
Yeah.
to wait until you have
I'm not sure I have.
Well, that's the body. Justin was talking about the arguments. The arguments come in unquoted or quoted, but the body still has to be quoted. I'm guessing.
Yeah. So this like returns a quoted expression, I guess. Like if I returned 1 here, I'm not sure what that would do. I think it would just, yeah, it wouldn't output 1 in the code. It would, I don't know, moving on. All right, so a good use case for these macros is ecto, which is the ORM for Elixir, definitely the only one that I know of. And it's really, really good. I wrote this thing called Baby Squeal that tries to do this, but is really, really bad at it. And it doesn't work this well. This is amazing. Like, so you say from fish and fish, and then you can get information about this fish thingy. And the in operator is what tells it, or the from is what tells it to do that. In does something as well, I don't know. And then you're saying, give me the fisherman. So you have a reference to what this association is now. So now you can say group by the fisherman name, and give me the max, length of the fish and the name. And what's cool is this select expression. So this says, give me back a list containing the maximum length and the fisherman name. But I could do like a map there, and it would return a list of maps. So basically, however you select it is how the data will actually come back, which is really nice. And if I said select, fish, comma, max fish.length, fisherman.name, it would give me, a list of the whole fish struct as well as those additional properties, which is nice. Active record is definitely not as nice to work with, I think.
Associate, is that an Elixir thing or that's an Ecto thing?
That is an Ecto thing, yeah. Yeah, that's probably, that's also a macro. So, yeah. And that just like reflects on the association and figures out, okay, what do I need here? They have a name for this, whatever this, they call this a binding. Fish and fishermen, they call them bindings. Not sure how that helps. That's all I got though. I just want to show you some things that I thought were really cool and I was impressed with. So, questions? No. Good. Bye.